Types of mode locking. There are mainly two types of mode locking in laser. One is active mode locking, another is passive mode locking. First, we will discuss about active mode locking, and we will discuss about this picture, and we will describe about active mode locking. So, uh, how the active mode locking works? The laser cavity has two main bands. One is gain medium and another is optical modulator. This is the gain medium, and this gain medium is where light is get amplified, and this optical modulator control or block the light. Now, this is the gain medium, and this is the amplified medium, such as doped crystal or semiconductor, where stimulated emission takes place. It provides optical gain to amplify the light passing through it. And then this is the a cavity length, that is L, the physical distance between two mirrors. This is 1 meter and another is another mirror. And this is the two mirror that determines the round trip TR of the light in the cavity, which is discussed earlier that TR is equal to 2L by C, and this 2L is this 2L is the length between two mirrors, that is, one is L, and this round trip, when it moves the round trip, then one is L and the return is L. That's why that is 2L, and that determines the round trip of the light in the cavity. And now the now this is the high reflector, a mirror that reflects nearly all light back into the cavity. You can see this is the path of light in which this is the high reflector, or you can say mirror. This mirror, by this mirror, the light can pass through the medium or laser resonator, and this is the output coupler. And what is the work of this output coupler? This mirror is a partially reflective that allows a small fraction of light to escape. You can see this is the intense band, but when it comes out of this light, this band intensity is decreases. This forms the laser output pulse. Now about the loss modulator. This is the optical loss modulator, where it uses like acoustic optic or electro-optic modulator that periodically changes the loss inside the cavity to actively synchronize the modes. This modulator is done at the frequency equal to cavity's round trip frequency. The optical modulator blocks the passage except when the pulse is about to pass. It will be open only during the pulse durations, thus creating a giant narrow pulse. You can and this active mode locking is used in continuous wave laser like ND-YAG laser, ND-YPO for laser, and this laser can produce pulse repetition rate between 80 to 250 megahertz and pulse energy in the nanojoule range. You can understand it by an analogy that imagine a laser light as cars going around a circular track. The modulator is like a traffic signal that opens for just one car each time it comes around, because it opens and closes at a fixed rhythm. Only car, that is pulses, that arrive at the right moment get through, creating a stream of equally spaced car or regular light pulses. So this is the graph, this is the time, and this is for the for the first one is for the loss, and this one for the pulse intensity. And this orange line represents the loss modulation inside the laser cavity. This is the loss, and this cyan color is the gain of the saturated gain after the mode locking. So this orange color curve is represent loss modulation inside the laser cavity, and the blue color curve represent the pulse intensity, and this is the gain or saturated gain of the active mode locking. So as we have discussed, the loss is created from the modulator and output coupling. So laser only emits strong pulses when this gain is greater than the loss. At that, so every time a pulse complete one round trip, the modulator reaches its minimum loss again exactly when pulse returns. So this is how the active mode locking works. Now the passive mode locking. In passive mode locking, we will see how it works. So it is a method of generating ultra-short pulses in a laser using non-electronic means like we have used in active mode, that is electro-optic modulator. Here we are using a saturable absorber. This is the saturable absorber. In passive mode locking, inside the cavity there are two main components like in the active mode locking, that is gain medium, and another is saturable absorber. This is the gain medium and this is the saturable absorber. The gain medium amplifies light, it gives energy to photon, and this saturable absorber acts like a gate that opens more when the light is intense and less when it's weak. Light travel back and forth between this mirror inside the cavity. This round trip light is marked as TRT, and that is the TRT. That is when light go from this mirror to this mirror and it return back to the same mirror. And this is the time TRT. Now, each time the pulse travel through, it get amplified by the gain medium. When it pass through the absorber, it reduces loss for strong pulses and absorb weak ones. Over many round trips, over many round trips, only short or strong pulses survive. That's how ultra short pulses are formed naturally without any external control, like in active mode locking. So this is the graph where we can see this green spike represents the light pulses or intensity, and the red line shows the loss inside the cavity. The blue line, this blue line shows the gain or energy supplied by the gain medium. So when pulse pass through this saturable absorber, the absorber becomes saturated and the loss decreases. That is loss this dip of this curve, and the pulse get amplified because of this gain, and that shows the dip of this curve, that is red curve, and the pulse get amplified because the gain is higher than the loss, and after the pulse passes through the absorber recovers and loss increases again. So only those strong pulses, this gain, after these strong pulses that can saturate the absorber will circulate continuously while weak ones fade out. So at that gain time, the it gives a high intensity pulse. So this that means the saturable absorber automatically selects and strengthens the strongest pulse, and every T TRT, one pulse complete a full trip inside the cavity, and the laser finally emit a train of ultra pulses, each which is separated by TRT.